The final example today, find A, B, and C in this picture. Now, with overlapping triangles to this point, we've had 2 unknowns at most, right? Now we got 3 unknowns because we have an extra property available to us because we have right triangles. Okay, pretend. Okay, let's use our imagination here. Do a little pretending. Let's see, I'm going to get a box here. I'm just going to cover this up like so. This was 4, right?
Yeah.
Suppose you saw that picture and your job was to find A. How would you find A? Pythagorean theorem. It's a right triangle, you're trying to find A. It gets stuck into this big problem here. It gets stuck into this and people just completely forget the Pythagorean theorem exists as a property. Okay? So just recognize pieces of things that have properties attached to them that you can use as you're doing it. So if I wanted to find A, it's real simple. A squared is equal to 4 squared plus 6 squared. You can see very clearly that 4 and 6 make the right angle, making them the legs. They go on one side. A is opposite the right angle, making the hypotenuse. It goes on the other side. That gets me A squared is equal to 52. So A is going to equal the square root of 52, which is about 7.1. 7.21 sounds good to me. 7.21. Okay. I do want that as a decimal. A couple decimal places, please. It just makes the rest of the problem easier if it's a decimal. The book, if you like to check your answers in the back of the book, I had no problem with that. When you get finished doing the problem, check your answers in the back of the book, see if you got it right, no problem. If you're using the back of the book to do the homework for you, that's wasting both of our time. Don't do that. Back of the book really likes to leave it as radicals here. But I like decimals. They're just easier to work with. So let's just go decimals. Okay. What I like to do is I like to copy that problem, that picture onto my paper, and as I find stuff out, I'm going to modify it, specifically A there. Now this is the same kind of problem the last problem was now. It's overlapping triangles. This angle is part of both the smaller triangle, 4, 6, and 7.21, and the bigger triangle, which is this side, which is how big?
10.
That side's 10. Again, 4 is important, but 10 is the length of the side of the triangle. And this side right here is how big?
C.
C, that's exactly right. And this side right here is now?
7.2 plus B.
7.21 what?
Plus B.
Plus B, very good. Plus B. So the B is not as important as 7.21 plus B. So, now we have 2 triangles, right? The angle down here in the corner is part of the small one and the big one. The right angle here equals the right angle there, which means that this angle has to equal this angle because that's the leftover angle of both triangles. If I'm going to set up a proportion for this, I do prefer to use proportions and scale factor when I start getting binomials. Just think it's easier to do with proportions. So 7.21 plus B is opposite the right angle. 7.21 is opposite the right angle. Those correspond to one another. 6 is opposite the blue angle, and 10 is opposite the blue angle. And let's call this angle here green. 4 is opposite the green angle. C is opposite the green angle. All right, so what's in black corresponds, what's in green corresponds, what's in blue corresponds. And what I want to do is I want to put all the pieces from one triangle on top. I'm going to put the 6 in the middle because 6 and 10 match. So 6 goes in the middle, 4 goes somewhere, 7.21 goes somewhere. Again, the reason I wanted 6 in the middle is because 6 and 10 are both numbers. I like my fraction has both numbers to be in the middle.
But
if you forget about that, it doesn't matter. I mean, I could have gone 6, 4, 7.2, and that's fine. It doesn't matter. What, Braden?
Isn't 6 and 10 part of the same thing, though?
6 is the measure of the small triangle,
I see.
and 10 is the big triangle. So they correspond. They're both opposite blue angles in their triangles. So the top numbers, again, 4, 6, and 7.2 will all come from the smaller triangle. 10 corresponds to 6. C corresponds to 4. They go in the same fraction. And 7.21 plus B corresponds to 7.21. So they go into the same fraction. This is a binomial. Put it in parentheses to treat it as such. Okay. The proportion there is going to be equivalent enough to get me what B and C equal. If I find B, or let's find C first. 6C is equal to 40. Divide by 6, divide by 6. round to a couple decimal places, 6.67. If I try and find B, there's my proportion. This product, 6 times 7.21 plus 6 times B is equal to 10 times 7.21. So 43.26 plus 6B is equal to 72.1. Move the 43.26 over. Is that like 28.84 maybe? 18.84? 28, I think 28.84, I don't know.
I have a question.
What's that?
How, why is it 72.1?
I did that product.
Oh, okay.
So you do this product and that product, I forgot to draw my arrow there.
Yeah, I
Thanks
got
for- so- But again, it's being multiplied by 10. So it's 18.84?
Yep.
Should have gone with my
28.
Oh, dang it. 28.84. That's what I said to begin with, and for some reason I was doubting myself. So 28.84. 6b equals that, so divide both sides by 6. We get, let's see, it's 4.867. 4.87? You got 4.806?
4.806.
4.81. Alright, 4.81. Go a couple decimal places in each of those. Again, it's just the overlapping triangles problem with the extra added feature of the Pythagorean theorem happening in it. So just make sure you do the Pythagorean theorem first. You see right triangles, immediately seeing right triangles, that should pop in your head every single time. Hey, maybe the Pythagorean theorem is going to happen to this. Alright, so keep that in mind. As soon as you see right angles, bring the Pythagorean theorem to the forefront in your thinking. As you find things, replace them, and then make sure that the sides are created properly for your proportions.